Hi, welcome back to my channel, and for today's video, I'm gonna fulfill my promise that I'm gonna provide a clarity video version of mathematical expression. So I'm actually doing this in the sense that the study of mathematical expression, the properties, some characteristics that you would really have to know is actually one of the fundamentals in learning mathematics. So almost everything that we've been discovering in mathematics are actually anchored to the concept of mathematical expression. So it is quite important, as my advice, that it is quite important that you should know the techniques, and some properties on studying mathematical expression. And on this video, I also like to let you know that I also have my plant here, the Sansevieria, and yeah, it's been a couple of weeks now that this is in my room. Although I actually took it out from the room to have it gotten with sunlight and a water sometimes. And anyway, before I'm gonna start with for today's video, I would like to give a thank to the people who have been supporting me. First things first, I'd like to say thank you to Jim Labahan for endorsing this channel to his friends, and thank you also to Daniel Vine Dondiano for being so supportive with me as well, for supporting this channel to her friends as well, and then introducing these to some of the students she knew back in their places, and also to Caitlin. And thank you so much for your support, guys. Okay, so when we say that it's a mathematical expression, we're actually referring to a mathematical sentence written with variables, numbers, and many more expressions. So let us consider this way. We have 3x plus 5. So this is actually a mathematical expression. So we can say this is an expression. In this case, the x here is the variable. And 3 here and 5 are actually constant. So it depends to what type of field they're coming from. So when we say we're talking about the set of real numbers, then 3 and 5 here are coming from the elements of real numbers. Okay, now to be more specific, this 3 here that is multiplied with the variable x, we call this 3 here as coefficient. And in the event that we are given with an expression, let's say 4x squared here plus 5, these 4 and 5 here are actually still constant, so they're coming from a specific field. And then your x here is variable. And the 2 here is actually the exponent. Technically, I would say x squared here is the variable. Now, the 2 here is the exponent, and the x here is the base. So, it is important for us to understand the basic concept, like terminology, that we are actually going to study in the mathematical expression, in the sense that they are quite important. They play fundamental role in analyzing how to deal with mathematical expressions. Now, for a given mathematical expression, let's say we're given with 4x squared plus 5. This one here is actually one term. This one here is actually one term. Which means to say that regardless regardless of the number of variables being combined, so long as you don't see any operations either plus or minus like this, so you don't see in between plus or minus between 4 and an x squared, then they are actually considered as one term. 5 here is another one term. So they're of different terms in the sense that they are now separated here with plus operation. That's it. There might be a lot more that I might miss in this video, but if you notice that there are a lot of questions that you might arise in your mind, you can comment down there so that I would know and I can discuss you that thoroughly. Anyway, I will introduce you a certain definition here. Definition is that for every n, so given that your n here is a natural number and any number a, let's say that our a here is an element of R. So to be general, I don't consider R. Instead, I consider a field, any field. Then a to the n implies that you have a times a up until a, and you're actually multiplying the n number of a's. Okay, so which means to say that let's say for example, if you're given with x to the 5, you're actually multiplying x by itself 5 times. Now, if your a is not 0, then okay, then the 0th power of a, denoted by this one here, is actually 1. So regardless how big the value of a is, let's say this is 550 raised to 0, that's always equal to 1. Okay, but you have to take note that there is a difference, because if you raise negative 5 to 0, that's equal to 1, because negative 5 here is considered as one entity. However, if you have to solve negative then 5, 0 here, or simply instead of writing there, putting a parenthesis here, let's say I'll just write negative 5 to the 0, then technically that's negative 1. So there's a difference. Unless you put the negative and 5 in just one entity by putting a parenthesis on it before you raise that to 0, then entirely that's equal to 1. That's it. And another is if your a here is not 0, then your n here is positive, then the negative exponent to a, denoted by, let's say, this one, this can be written as the reciprocal of the positive exponent. So meaning to say, if you have, let's say, x to the negative 5, that's equivalent to 1 over x to the 5. Okay? If you have 1 over x to the negative 3, you can write that actually as 1 over this one here, you can write that as 1 over x to the 3. So technically, that's 1 times x to the 3 over 1, that's x to the 3. That's it. Okay, so this definition I've shown you here is actually one of very specific example of the laws of exponent. So I'm gonna introduce another thing here. Let's say I'll just label this number 1, meaning to say number 1 right after the I have introduced you the basic definition. So if you have x to the m times x to the n, so that means to say your x here is any field element, then your m here and n here is a real number. So they're actually constant. So if you do the multiplication of these two, you're actually copying the base and then you add the exponent. Okay. So I'm gonna use this condition in general to introduce number 2. So if you have x to the m, then that is to the n, you're actually getting the multiplication of this one, of the exponent. That's it. And so, by that, I'm gonna introduce a corollary to this number 2. That means it's a consequence based on the fact that the technique on showing this whether it's true or not is actually the same. I can have negative m, and this is quite the same as, and so this is equal to that one. Okay. Another is if you have this one, these have different cases. You can have x to the m minus 1. That means you're actually subtracting them if m is greater than n. Okay. This is actually 1 if m equals n. And finally, this is equal to n minus m if m is less than n. Okay. So I'm gonna show an example for this. Let's consider this example. I have x to the 5 over x to the 3. Now, if you notice, your 5 here is the m, your 3 here is the n. So, m in this case is greater. So, that means we're following this rule. So, we can copy that one, x here, and then 5 minus 3, you get 2. So, the answer is x to the 2. Okay, let's try another example. We have x to the 4 over x to the 5. Okay. Now, x to the 4 equal over x to the 5. So in this case, n here is greater. So we will follow this rule. So that's equal to 1 over x to the 5 minus x to the 4. That's x to the 1. In this case, I'm gonna write x to the 1 as x. So that's 1 over x. Now, which means to say that this example will introduce another definition that x to the 1 is simply x. That's it. Okay, so because we're actually studying with the expression, so before I forgot of telling you that let's say this 4x squared plus 5 is actually an expression. This one here, 3x minus y, that's another expression. So in this case, if you're gonna equate that to, that means 4x squared plus 5 equals 3x minus y, we no longer call this as expression entirely, but this is now an equation. Which means to say that we can write a formal definition that an equation is an equality of two expressions. That's it. Okay, so let me introduce the basic of adding expressions. So let's start. When I say add, I also mean minus, subtract, which because when we do addition and subtraction, they actually come hand in hand. Subtraction is actually just the additive inverse of addition. So when I say addition, we have certain rules to follow. First is we can add similar terms. Okay, so meaning to say that the similar terms can't be combined. Okay. That's it. So, number 2. When adding terms, so aside from checking if they are actually similar, if we just copy the variables and add the coefficients. Okay. So which means to say that the thing that we evaluate whether terms are actually similar or not is just looking at the variables, not on the coefficient. Example, 4x squared, 3x, and 5x squared. So the only thing we need to evaluate, we can't exclude the coefficient. So what are the coefficients again? This 4 here is a coefficient, 3 is coefficient, 5 is coefficient. Meaning to say that x squared is the variable, x is a variable, x squared is a variable. So in this case, 4x squared and 5x squared are actually similar terms. So 3x is not. Therefore, according to rule number 1, you can only combine or you can only add similar terms, and the similar terms can't be combined. So if I'm gonna add these 3 here, my final answer would be, according to rule number 2, when adding terms, just copy the variables. So I'm gonna copy the variables, which is x squared. And then I will add the corresponding coefficient. 4 plus 5, I get 9. And then, assuming this is plus here, this is plus here. So I have to copy 3x. That means I did not do anything on 3x, in the sense that we can combine this one to the other variables, in the sense that this is the similar to the other. So that's it. That's now the final answer. We cannot do anything about that yet anymore. Okay. Okay, another rule is, when adding terms, okay, you have to add similar signs. Okay? So example, one is positive, one is positive, so you can add similar sign and then copy the common sign. Okay, if the similar sign, so that means different sign, subtract. So you're not gonna add but subtract. And then after subtracting, copy the sign of the larger value. Okay. Example, I have 4x cube. This is one here. Another is negative 7x cube. So let's evaluate first. According to 1, you can only add similar terms. So they're similar in the sense that the variable of 4x squared, x cubed rather. Why did I read this as x squared? So the 4x cubed, the variable is x cubed. For 7x cubed, the variable is x cubed as well. So you can add them. Okay, no problem with rule number 1. For rule number 2 is, you just have to copy the variables and add the coefficients. So, I'm gonna copy the variable here. So, x cubed. I'm gonna add the coefficients. So, for me to be able to do that, I'm gonna check the rule number 3. Rule number 3, are they similar? Are they having the similar signs? So, one is positive, one is negative. So, I'm not gonna follow this, but I'm gonna follow that. So, the similar sign means you subtract. So I'm gonna subtract 4 and 7. I'm gonna get 3. Then copy the sign of the larger value. So which is larger, 7 or 4? Here in this case, 7 is larger. What's the sign of 7? It's negative. So I'm gonna copy 3 because that's the subtraction. I mean, that's the difference when I subtract 7 and 4. And then I'm gonna copy the sign of the larger, which is negative. So this is my answer. That's it. Okay, so let's provide further examples. Assuming I'm interested here, adding this term. Okay, so I'm interested to solve these terms. So that means I'm interested of adding the terms, I mean the expression 4x squared minus 6x minus 7y plus 5 to that expression 3x squared plus 4x minus 6. So I'm gonna add similar terms according to rule number 1. So similar terms here is this. Okay, so let's start with this first one thing here. Then I'm gonna copy the sign. So I have x squared. And then I'm gonna add coefficients. Before adding, I'm gonna check, though they have the same sign. 4x squared is positive, 3x squared is positive, they have the same sign. So according to rule number 3, they have similar sign, so copy the common sign, just add. Okay, I add 4 and 3, I get 7, and copy the common sign, so that's positive. Okay, next similar terms is 6x and 4x, so here. Okay, just copy the variables. I'm gonna copy the variable x here, and I'm gonna add 6 and 4. In this case, however, they have dissimilar signs. So 6 is negative, 4 is positive, so I'm gonna subtract them. The answer is 2, and then I will copy the sign of the larger value. So that's 2, then this is negative. 7y. This case doesn't have anybody here from this group of guys here that has the same term with 7y. So that means we can't combine anything on 7y. So just copy 7y. So that's negative 7y. 5 has the same term with negative 6. Why? Okay, here's the thought about that. 5 here can be written as 5x to the 0. Remember, any value that is raised to 0 is 1. So that's technically 5 times 1 equals 5. So same with negative 6. So that's negative 6x to the 0. And that's equal to negative 6. So that means they have the same variable. Meaning to say, I can add them. 5 is positive, 6 is negative, so I'm gonna subtract, I get 1, and then I copy the sign of the larger one. So therefore, this is now the final answer. That's it. Okay, another example. Let's try 8x 5 plus 4x cubed minus 3x squared plus 1 minus 4x5 minus 7x squared plus 4. Okay. Okay, if you do subtraction, here's the thought. You need to copy the first. So this is the first expression. So I'm gonna copy this one. And in this case, this is minus, so I'm gonna change the sign here. Later on, you will understand the reason why there actually changes when I explain to you the next topic right after the addition of expressions. So here in this case, this is positive, so I'm gonna write that as negative. This one is negative, so I'm gonna write that as positive. This one is positive, so I'm gonna write that as negative. Sorry, why did I put x here? Okay, and then I can proceed now to operation. So this one and this one have the same terms, so they have the same variable. So which means to say I'm gonna copy the variable x to the 5, and then I'm gonna add 8 and 4. 8, they have different signs, so I'm gonna subtract, so I get 4. I copy the sign of the larger one, which is positive, so I'm gonna have 4x to the 5. Next is I'm gonna check x cubed. X cubed doesn't have a pair here, so that means to say I'll just copy the x cubed, so that's 4x cubed. X squared has the same pair with the other, so that means 3x squared. I also have 7x squared. Rule number 2, you just have to copy the variable and then add the corresponding coefficient. However, they have the similar signs, so one is positive, the other one is negative, so I'll get the subtraction. So 3 minus 7 or 7 minus 3, you get 4. And then which one is higher? The positive 7, so that's positive. And then I have finally 1 and 4. So you can have the difference. So you need to subtract, which means to say that you have minus 3. So this is now your final answer. That's it. Now that we're done with addition of expressions, so that means we're referring to addition and subtraction of expressions, we will introduce the multiplication rule. So when I say multiplication, we're also referring to division. Okay. So when multiplying expression, number one rule is you can multiply anything. So multiply anything regardless of whether similar terms, similarity of terms. So whether they're similar terms or not, you can multiply them. So that means each term of the first expression, each term of the first expression shall be multiplied to each term of the second one. So if you're multiplying more than two expressions, then do the same process when you're done multiplying the first two. And then here's the difference. Here's another rule. Same signs, you get positive. Different signs, you get negative. When I say same signs, I'm referring only to two terms. So let's say, for example, if you have same signs, there are three terms. So that's a different story, which I can provide another explanation for that later when we're actually doing with examples. But in this case, when I say same signs, I'm only referring to two terms. Different signs, I'm also referring to two terms. So that means if you multiply positive and negative, the result is negative. When you multiply positive and positive, you get positive. You multiply negative and negative, so they're different signs. They're the same signs, although they're negative, but the result is positive. That's it. And then for number 3, follow exponent rule if necessary. And follow addition rule in case if necessary. Okay, so let's check via example. Number 1, I'm interested to multiply 4x 3, multiply that by 3x 4. Okay, so I can multiply them together. And so I will multiply the coefficients here. So 4 and 3 and 4, I can have 12. Now, x cubed and x to the 4. So if you remember earlier, the exponent rule, x to the m times x to the n, that means they have the same base. So you just have to copy the base and then add the corresponding exponent. So this is what we are going to do here. Copy the base, which is x, and then add the corresponding exponents, which is 7. So therefore, your answer is 12x to the 7. Okay, number 2. Let's say I have 3x plus 5. I also have 3x minus 5. So the rule here is, according to number 1, you multiply anything, they have the same terms or different terms. Then there's a corresponding rule. Each term of the first expression shall be multiplied to each term of the second. So meaning to say, the first term is multiplied in each here. And each term here is also multiplied to here. Okay, so let me try multiplying that first. 3x times 3x. Okay, that's it. Then 3x times 5x times 5. So I have 3x times 5. They have different signs. So according to the rule, different sign is negative. So this is negative here. Plus, let's go with 5. So 5 and 3x. So I have 5 and 3x. And 5 and 5. So they have this different sign. So this is minus. Okay. Now let's follow the exponent rule. You can multiply 3 and 3, you get 9. Exponent rule is 1 plus 1 for the exponent, so you get x squared. This one also is 15 and just x because there's no other corresponding x. So this is just equivalent to x for this one here, so that's 1. This one doesn't have x, so that is equal to x to the 0. So 1 plus 0, you get x. So that's x here. Okay, plus, that's another 15x, and that's 25. Okay. So if you notice, they have the same term. So according to the addition rule we've discussed earlier, this one here can be added. So they have different signs, so that means you subtract. So 15 times minus 15, you get 0. So you don't need to check anymore the sign because that's automatically 0. So you have to copy 9x squared, and that's negative minus 25. What do you notice here in this example? Well, it follows a certain pattern. Because if you notice, the first term and the first term of the second expression have the same. They have the same term. The second term and the second term of the other expression are also the same. The only thing that differs is the sign, which means it plays a corresponding pattern. We call that one as a special product, and I have already discussed that on my previous videos I have uploaded before. Okay, so here's the video for that if you're interested. Okay, another example. I have 3x. I have negative 2x. Negative. This is negative 7. Okay. According to the rule that if they have the same terms, the same signs, you automatically follow positive regardless whether it's positive or negative. So if they're different, then automatically it's negative. But there's a but. Again, as what I've explained earlier, we're only referring to 2 terms. Now, in this case, for number 3, there are 3 terms. So what are we gonna do is we have to examine the first 2. You just have to choose the two of the terms there that you have to combine before you combine the third one, so that you're still following the rule of sign. So in this case, I'm gonna follow this first. So 3x and 2x, so I'm gonna multiply that, I get 6, and then x squared because I'm adding exponent. In this case, there are 2 terms, so same sign, so that's positive. And then in this case, this is 7. So 7 times 6, I get 42x squared. However, different sign, negative, positive, so this is negative. So if you notice, although they have the same signs here, the final answer is negative in the sense that they're all negative, but that's more than 2. So that means the pattern is, I'm gonna put an additional rule. Similar terms, similar positive terms, all are positive. But similar negative terms, the result is either positive or negative. Okay, here's the thing. Similar negative terms is positive if even number of terms. Negative if odd number of terms. Meaning to say that if you double check the question, the previous example, they're all similar. They're all negative similar terms. So you follow this rule not on the first, this one here, but this one. But if you count the number of terms, 1, 2, 3, so 3 is odd. So odd, that's negative. Okay, so that means to say if you have negative 2, negative 2, negative 2, negative 2, so that's equal to 16. That's positive in the sense that they are similar negative terms and even number of terms because there are 4 terms. So automatically that's positive. That's just a technique or an understanding how to add or multiply mathematical expressions. Okay, so this is just a short video. Just a brief video discussion for introduction to mathematical expressions. So I call this as mathematical expression version 2.0 in the sense that I already have provided this video before, but I just want to make it clear because I'm so sorry the last time that I was just new in making videos, so I didn't know how to edit videos. So it wasn't clear, and I was actually aware of that. I'm so sorry. So this time I'm gonna make sure that I think my writing here is clear, my video here is clear. If you have any questions or clarification, just comment down there so that I would know and I can discuss you that thoroughly. And I hope to see you on the next video. So that's all for now. Thank you so much. And by the way, you can comment down there if you would want me to discuss a specific topic that you would like me to discuss. In that way, I can help you with your online classes as well. Thank you guys and have a great day. Bye!